To illustrate how to compute probabilities using the uniform distribution, suppose that Southwest Arizona State University provides bus services to students while they are on campus. A bus arrives at the North Main campus and College Drive stop every 30 minutes between 6 a.m. and 11 p.m. during weekdays. Students arrive at the bus stop at random times. Assume that the time a student waits is uniformly distributed from 0 to 30 minutes. Given this information, we do the following. 1. Draw a graph of the distribution. 2. Show that the area of this uniform distribution is 1. 3. How long will a student typically have to wait for a bus? In other words, what is the mean waiting time? What is the standard deviation of the waiting times? 4. What is the probability a student will wait more than 25 minutes? And 5, what is the probability a student will wait between 10 and 20 minutes? The graph of the uniform distribution for the bus problem described in the previous slide is shown here. The horizontal line is drawn at a height of 0.0333 found by 1 divided by the difference between 30 and 0. The range of this distribution is 30 minutes. To show that the area of the distribution is 1, we apply the formula 1 divided by the difference between 30, the largest point of the distribution, and 0, the smallest value of the distribution. We then multiply the resulting number by the difference between 30 and 0. The product is 1 minus the area of the uniform distribution. To determine the average amount of time a student has to wait for a bus, we apply the formula for the mean of a uniform distribution. We add the lowest and the largest values of the distribution, which is 30 plus 0. Then we divide the resulting sum of 30 by 2. The mean waiting time is 15 minutes. Next, we compute the standard deviation of the waiting time. This is done by getting the square root of the value after we divide by 12, the square root of the difference between the highest and lowest points of the distribution. Here the standard deviation is 8.66 minutes, which measures the variation in the student wait times for the bus. In the uniform distribution, the area between 25 minutes and 30 minutes represents the probability that a student will wait more than 25 minutes. This area is the orange shaded portion of the uniform distribution as shown on this slide. We compute this probability by multiplying the height of the rectangle, which is 1, divided by the difference between 30 and 0, by the base, which is the difference between 30 and 25. We obtain an area or probability of 0.1667. What is the probability that a student will wait between 10 and 20 minutes? The area between 10 and 20 minutes represents the probability. We obtain this probability by multiplying 0.0333, the height of the rectangle, by 10, the difference between the two times of interest, 20 and 10, which is the base. So the product of the base 10 and the height, 0.0333, is 0.333.